Hello everyone, my name is Vedannath. So I'm here today to present you functional programming in Java. So I'm a developer by profession and a trainer by passion. So today, as I've told you, I'll be dealing with functional programming in Java. At start off, so I have been doing this from quite a few months. And in the last session, also I had a little bit discussion on the functional programming. So today, I will be dealing with a topic called streams. So streams are a very essential part of functional programming. So whenever I talk about a stream generally is nothing but a flow of code, a flow of information in a program. So whenever I talk about a stream, so when from the inception of Java, stream was not available as a part of Java programming. So slowly, when they had tough competition from programmings like Python and other programming languages, slowly they introduced this in Java 8. So as you can see from Java 8, the stream API was started to be used. So when they started it, so it was an API which was used for processing the collections of objects. So collections, exactly, I mean collection of elements. So collection of elements can be a collection of numbers, collection of strings, collection of various data elements. Okay, so various collections of data elements or collections are nothing but collection of elements. So generally we have a separate collections package from java.util, so which will deal with the collection. So we'll be seeing how we can deal with the collections and everything. And generally, as I've told you, a stream is nothing but collection or flow of data. So a stream is nothing but sequence of objects. So generally, I said you collection. So where collection again is given in various terminologies like list. You have a set collection, you have a map collection. So a stream is nothing but sequence of objects which will process those collections, So a stream is nothing but a sequence of objects that supports various methods. So generally, those all methods what are available under the stream are pipelined exactly. So pipelined in the sense, so they will be going in a sequence doing their activities. So whenever I say pipeline, so pipeline in the sense, so they will be acted in a sequence. A stream is, so once again, you can see a stream is a sequence of objects. So sequence of objects in the sense, so what I have here, so I have the sequences. I mean, I have the objects which are put in a sequence, and the various operations will be done on that collection, will be done on that sequence with the help of some internal functions. So we'll be understanding what are those functions, which will be telling you about the functional program. So then generally, whenever we talk about collections, whenever we talk about data objects and everything, so people often get confused that this is nothing but a data structure. So, but definitely, I want to make it clear that it is not definitely a data structure. Okay, so it is definitely not a data structure, but it generally takes the inputs from the available resources such as collections, arrays, or input-output programming. Okay, so once again, I'll try to clear you this. A stream is not a data structure. So generally, whenever I talk about a data structure, we generally think the data structure is something like a stack, queue kind of thing. So generally, this data stream, or you can say a stream, is not a data structure. So it takes the input from the collections, definitely. It takes the input from the arrays or other resources such as IO, but it is not a data structure. Okay, so to give you a clear idea about all the things, what I've told you, it's an API. So stream is an API which will process the collection of objects. So a stream is a sequence of objects. A stream is sequence of objects which will support various methods. So those methods are generally pipelined. So pipelined means so they will be doing their activities one by one. Okay, so that is what it is. And one point to be cleared, which is that is not a data structure. So it is not a data structure. Okay. So whenever I'm saying stream, so what we think is, so some of the operations are going on strings. So we might think that there will be a change on the original structure or the original collection. So there won't be any change on the original collection, definitely not. And they will provide the result as per the methods that you use. Okay, so you don't worry what are the methods. So we are going to deal with all the methods right now. So what point is that I'm talking about? I'm talking about a point here, which is saying that the streams will never change the original data. So the original copy will never be changed. The original copy will never be changed. The original copy will never be changed. And what you get the result out of the methods that you use. So you get the result out of the methods that you use. Okay, so what are those methods? Those methods are also known as functions. So they are also known as simple operations. So we put them into two. One is intermediate operation and the other one is terminal operation. So intermediate operation is nothing but we will have some operations, or you can say some functions, which will be dealing with the operations which will be helpful for working on that collection object or an array object. Okay, so then in the next we will be understanding the terminal operation. So what this terminal operation will do, or terminal operation will be helpful for generating the results exactly. So these terminal operations are used for generating the list, generating the result, and the intermediate operations are doing some operations on the collection. Okay, so what are the two operations? Intermediate operations as well as terminal operations. So these two are pipeline. So these two are pipeline. So these two are pipeline to get the result. So these two are pipeline to get us the result. So to give you a summary, what is a stream again? A stream is nothing but an API. So it is an API which will be used to process the collection of objects, and it is nothing but which will be working with the collection of objects. Will be working with collection of objects where some of the methods are pipelined. So what are those methods? Those are intermediate operations or intermediate methods, or you can say terminal operations or terminal methods. So methods, operations, functions, so they're all kind of synonyms to the tasks which are to be operated. Okay. So before going to those terminal operations and the intermediate operations, so let us have a discussion on exactly what is a stream and how you create a stream. Okay, how you create a stream. So the stream can be created in various ways. So we are now going to look at how we can create an empty stream. So in order to create an empty stream, so we generally have to use a empty method. So we have to use a empty method. So what we are going to use here, so we are going to use an empty method. So what this empty method is all about? This empty method is all about creating an empty stream, So here you can see we are using an empty method on the stream. So stream, so what it is going to give you, it is going to give you a stream object. So it is going to return you a stream object. So what we are doing, so we are storing that in a variable called stream empty. So here stream empty is a variable which is of type stream. So which is a string at the end of the day. So it's a string. So if you try to, so here is a simple terminal method. So terminal method or a terminal operation called collect. So this collect is nothing but the collection of the object. So collection of the object that we have. So we'll talk more about collect. So just try to understand here, because when I just print stream empty, so you won't be getting any string object, because so everything has to be shown with the help of some kind of terminal operation. So here collect is one of a terminal operation. So one of a terminal operation. So where you say stream empty dot collect collectors to list. So exactly that object, whatever we have created, it will be shown to you like a list. So that is what the point. So here, as it is an empty, so we don't see any element. So we don't see any element. So it is an empty list. It is an empty list. So stream empty. So what we have created over here, we have created an empty structure. So we have created an empty structure. So that we can have no elements in that. Okay. So in the same way, we are going to create a stream of collection. We are going to create a stream of collection. So when I am talking about a stream of collection over here, so what we are going to do, so we are going to create a collection, we are going to create a list, or we are going to create a set. Okay, so when I'm saying empty, we don't have any elements. But then when I'm saying collection, there might be some elements. So there might be some elements. So exactly what we are trying to do over here. So we are trying to have a collection. We are trying to have a collection. So if you look at the right, so it is arrays dot. So arrays is one of the packages that we have under java.util.arrays. Arrays.as list ABC. So what is this ABC? So ABC is a list. So that list is a collection of string type. Okay, so what we are trying to do now? So we are trying to have a stream out of it. So we are trying to have a stream out of it. So if you can see here, collection.stream. So what exactly it is going to give you? It is going to give you a collection of string. Again, you see here. So we need to use collectors.toList. So exactly what does it do? It will give you a collection of strings. So I mean a list of strings. So what exactly we are doing? So for getting the collection of strings, so we are saying stream of collection. So what is the stream of collection here? Stream of collection is the variable that is returned from collection of string. That is returned from collection of collection.stream, and from that we are going to get a collection. So what exactly it is of? It is of an arrays.asList ABC. So what we are creating here, we are creating a stream of collection. So previously we have created a empty string. So now what we have a collection of strings. We have a collection of strings. Okay. So we have collection of strings. So now the next thing that we are going to look at is a stream of an array. So a stream of an array. So what exactly is a stream of an array? So an array. So as we know, an array is a collection of elements. So basically, when you talk about Java programming, so Java programming from Java 1.2 version onwards, so there was inception of collection. So before that, the collection of elements was only array. Okay, so collection of elements was only array. So what was array? Array is also a collection, but generally it is a static, or you can say an homogeneous collection. But when collections came into the picture, so we have all kinds of elements. So here what you can say, so we are saying stream dot of ABC. So what we are doing here, we have created, so this is an array. So this is an array of elements A, B, C. So now what we are doing, so we are going to create, or we are going to make that array into a stream. So what we generally are saying here, we are saying arrays dot stream. So with that, what will happen? That array, whatever we have created, that is ABC array. So that will be converted into a stream, converted into a stream. So converted into a stream. So now when you are saying, when you are saying an array, so an array, so where we are saying an array, in the first line, you can see the whole array being transformed into a string. But in the second line, when you observe, so we see that elements 1, comma 3. So generally, whenever I'm saying 1, comma 3, so 1 is the index and 3 is the end index. So 1 is the start index and 3 is the end index. So where we don't involve 3 exactly. So it is 0, 1, 2. So 0 being A, B being 1, and C being 2. So when we say 1, comma 3, so generally 3, so we also call it as an offset. So that won't be involved in the result. So what exactly I'm trying to say here is, I'm trying to say that when you say stream of array full, so which object is that? So that object is the full array, which will get you A, B, and C. And when you look at the part, so what it exactly is going to do? It is going to give you only BC. Why? We said array 1, comma 3. So we said array 1, comma 3. Array 1, comma 3 results in what? So array 1, comma 3 results in only two elements, that is 1, 0th, so first index element and the second index element. So this is where you create a stream of array. And then we have something like builder in stream. So what we are going to do in this, we are going to build, okay, so we are going to build a collection of, elements. Okay, so generally this add is used in collections. So we have a collection called list collection. So wherein we have array list, linked list, stack, vector. So in that we generally have elements added to the list using add methods, So but what we are doing over here, so we are trying to use a builder. So which can add the elements A, B, and C, A, B, and C to the list. So exactly what is happening here? We are creating A, B, and C that were added to the list. So exactly what it is? It is nothing but a stream builder. So it is nothing but a stream builder. So when I'm saying stream builder, so what exactly is a stream builder? So stream builder is nothing but that is helpful for building the elements, or you can simply say adding the elements to the stream, So exactly what we are trying to do over here, we are trying to add the elements. So we are trying to add the elements into the, list. Okay, so yeah, so we are trying to add the elements into the list. Okay, sorry for that. Okay, so next we have the generate. So we have the generate. So when we say generate, so what exactly is generate going to do now? So generate is also a method. So which will take, so what is generate here? So generate method which will take, okay, so supplier element. So generally when you have a Java collection, so you have something like separate and supplier. So you don't have to worry about that right now. So when we are saying generate element dot limit 10, again, what we are trying to do here, so we are trying to generate. So what is the generate method? Generate method will be trying to take up a collection of elements. So trying to take up a collection of elements. So this is the beauty of functional programming, where we don't try to put any collection or anything, but we still get a collection of elements. So what exactly we are trying to do here? We are trying to have a stream generation. We are trying to have a stream generation, so which will put element into the, so which will put an element. So element is a string here, which will put element, that is a string. So what we are going to give, we are going to get 10 elements. So we are going to 10 elements. So what exactly that we are trying to say here? Creates a sequence of 10 strings with the value element. So what it is going to do here, it is going to create a sequence of 10 strings. So what exactly I'm trying to say? I'm trying to say that, okay, so once again, we'll just try to go here. So what we are trying to say here, so stream string generated. So what we are trying to say, dot generate. So previously what we have seen, that, so builder, okay, so now we are seeing generate. So what exactly generate is going to do? Generate is going to do here in this case, of course. So here it is going to create element string, that to how many elements? So 10 elements. That to how many elements? 10 elements. So it is going to create a sequence of 10 elements. So element here is the string, basically. Element here is the string. So what exactly I'm trying to say, a generate is used to generate the elements. So depending on the limit, that you are providing. So limit that you are providing. So that's what the point here. So whenever I'm trying to say generate, so generate is going to give you, what? So generate is going to give you the elements. So generate is going to give you the elements depending on the limit. So depending on the limit. Okay. So next we have something like iterate. What exactly is iterate? So you can see variety of methods here. Like you say generate, so it will generate some list of elements. You say build, so it will be helpful for building the elements. And now you are able to see iterate. So what exactly iterate is going to do? So iterate is going to, so here suddenly we have used something like integer. So what exactly this integer is? It is known to be a generic class. It is known to be a wrapper class. It is known to be a wrapper class. So that wrapper class, so we are handling here by the help of a generic program. So here, what exactly we are going to do? Iterate 40. So my 40 value is going to be the n value. So my 40 value is going to be the n value and start value. So 40, now 40 is the start value. And what exactly to happen in the collection here? Every value from 40 to be increased by 2, and it has to take a limit of 20 values. Means the first value being 40, and the second value being 42, third value being 44. So exactly what I'm trying to say here is, the first element of the resulting stream is the first parameter of the iterate method. The first element generally is 40. So from then on, so it will be like 40 plus 2, then 40 plus 2 is nothing but 42. So then again you get 42 plus 2, then you get 44 plus 2, then you get something like this. So here you can observe that we are having, the elements. So what exactly it's happening over here? So exactly 40 is the first element. So 40 is the first element. And from then on, you have 42. So then 44, then 46, then 48, then 50. So how many numbers in that way? 20 numbers. How many numbers in that way? 20 numbers. So that is what is limit. What was generate all about? Generate was all about. So what was generate all about? So generate was all about generating a limit. So on the given element. But iterate is what? Iterate generally takes a start number and the number from then on. Okay. So that was the iterate method. So that was the iterate method. And next, we will be looking at stream of strings. So when we say stream of strings, so what is a string exactly? String is a collection of characters. So generally, whenever I'm talking about a string is nothing but collection of characters. So when I take a string, so that generally I will take under the quotes exactly. So when I'm saying string, so string is a collection of characters, something like this. So now what I'm saying here is ABC dot characters means put this ABC into characters. Put this ABC into characters. So what exactly we are saying? String as a source for creating the string with the help of the chars method. Which method? Chars method. So what does this chars method do? Chars method will make you the elements, okay, so we'll make you the elements A, B, C to be a part of this. So this is where your stream of strings will be used. So these are the methods that we have used. So to make a list of all the things, so we can just go back to all the things. So what all we learned on stream methods. Okay, so I'm just going back. So once I go back with all the things, so you will understand what all we have done. So we have created an empty stream. We have created an empty stream. So then we have created a stream of collection. Then we have created a stream of collection. So then we went for a stream of an array. So then we went for a stream of an array. So where we had indexing of the stream as well. Okay, so indexing, or you can say slicing on the stream as well. Then we went for building of the stream. So what exactly was building of the stream? Building of the stream was, so we were trying to add a collection of elements, and then we went on to see something called generate. So where we generated a collection of strings. So where we generated a collection of strings. And then slowly we went on to the iterate method. So what exactly was an iterate method? Iterate method. So iterate method, generate method. The difference is iterate method will take an element. Iterate method will take an element. So take an element at the start. Take an element at the start, and that will be the first element, and the last element will be decided by the limit. Will be decided by the limit. So that's what the point is. And then we also went for the creation of a string. So for the creation of the string, and then now we are going to look at the intermediate operation. So what exactly were intermediate operations? Intermediate operations were the operations that were used for the pipelining. Used for the pipeline. So what exactly was pipelining? So pipelining is nothing but a pipeline of methods used for the stream. Pipelining of methods used for the stream. So the first method under the pipelining methods of intermediate operation is map. So whenever I come across this map, I say that mapping is nothing but a map of one element to the other. So, or one thing to some operation means, so you are mapping an element to an operation. So exactly I mean by map is to map an element to an operation. So the map method is used to return a stream of the results. So consisting of the results of applying the function to the given element. So I have a function. That function generally is mapped to all the elements. So that function generally is mapped to all the elements. So one function which I will map to all the elements. So map to all the elements. So that's what the point. So this is what the package, Java.util package, which will contain all the classes. There's no we have used something like arrays. Okay, all those were the parts of java.util package only. So then here we are going to create a class called map demos. As you know, all these things are quite common for creating map and all. So now we are creating a list of integers. So generally how I can create a list of integers, I can create a list of integers by having a simple list. So this is a list interface exactly. So this is a list interface. So what exactly list interface is? List interface is nothing but a collection interface. So which can have a list of elements, a list of elements. So as I've said, list is an interface. So you cannot say new list and all. So that will not be helpful for us to create the list. So arrays.asList 3 comma 6 comma 9 comma 12 comma 15. What exactly these elements are? So these elements are going to be, so what these elements are going to be? So these elements are going to be the list of elements. Okay. So this is the simplest way to create the list. Simplest way to create the list. Otherwise, when you are using something like array list, so you have to add the elements one by one. Okay. So this is the best way. And now we are going to use a map function. So using stream map. So generally map is nothing but a stream map. So map is nothing but stream. Okay. So what exactly I'm going to do here? List dot stream. So what is list here? List is list of numbers dot stream. So we are making it a stream of elements. So on that stream of elements, we are applying a map function. So where number is mapped to number into 3. So number is mapped to number into 3, where each element is taken as the number. Each element now is taken as the number. So now you can see. So this each element, whatever we have provided in the list is taken as a number. So that number into 3. So number into 3. So 3 into 3. So 3 into 3. So which is nothing but 9. So now what will be the first result? So 9. So what exactly I'm doing here for each? So and now for each is again a terminal operation. So we'll know about it. We'll know about it for each. So each element to be printed, each element to be printed. So this is known as the scope resolution operation on system.out. So system.out. So what we are going to do here, what we are going to get here. So we are going to get 9, 18, 27, 36, and 45. So what exactly this is? So this, okay, so let us go in reverse and understand. So for each, we are printing which elements? We are printing the elements which are multiplied by 3. So what are those elements? Those elements are from the stream, which are mapped one by one, which are mapped one by one. So one by one, each and every number is mapped with mapped with number into 3 functionality. So number into 3 function. So that is where each and every number is getting multiplied. Each and every number is getting multiplied. So multiplied, and then that is going to be printed. So that is where you use for each. For each is nothing but a terminal operation. So this is a map. So what exactly is a map? So map is nothing but which will map a functionality to each and every value of the stream. Then comes filter. So map was applying some functionality for each and every, applying some functionality for each and every element. So whereas the filter will filter out, for example, I want only numbers which are divisible by 5. So I want only numbers which are divisible by 3. So in that way, I can filter out the elements. So filter out the elements. Okay. So now importing and all common things. So I'm not including them here. So now these are all common things to run a program. So now here what I'm having a collection of strings. I'm having a collection of strings, or I can say a list of strings. I'm having a list of strings. So 1, 2, 3, 4. So previously what they were? Previously they were collection of numbers, collection of integers rather, collection of integers, because the list was intended to have an integer only. The list was intended to have an integer only. But now if you observe, so the list can contain a string. So this is where your generic will come into the picture. So as you say string, you need to have strings only. So as you say integer, you can have only integers. So you can make your list. So you can make your list to hold the type of element that you want. So you can make your list hold to the type of element that you want. Okay. So now, so if I am saying system.out.println, so what exactly I'm going to print now? I'm going to print all this data. I'm going to print all this data. Fine. Then now what I'm trying to do here, so basically I can put dot one after the other, but when I transform this from a program, so that is where you get they get them scrambled everywhere. But anyways, so you can use it in a sequence. So what we are saying here, numbers. What is numbers? Numbers is this stream dot map. So what we are doing here, we are mapping each element from the stream. We are mapping each element from the stream. So they might be strings over here. They might be strings over here, definitely. But I want to convert them into integers. I want to convert them into integers. So where I'm taking each element, so I'm using a map also, because already we learned map. Already we understood what was map. So what was map doing? Map was taking each element from the collection and working on a functionality. So here the same thing. What it does, it takes each element from the stream. So what is stream? Stream is nothing but flow of elements, right? Flow of elements from the collection. So that's what we learned in the beginning. So stream dot map. So what we are doing, each element is getting converted into, each element is getting converted into an integer. And now we are going to add up a filter. So what is exactly this filter is going to do? Filter is going to take each number from this stream. Okay, so how it can be confident that it's a number? Because we have mapped each string into an integer. We have mapped each string into an integer. integer. So now you can see that that is being changed to a number. So that number, it is being checked. It is being checked. Is that number perfectly divisible by 2? If it is true, then you collect all that numbers. You can collect all that numbers and print. So now, for example, I get 1. So 1, first thing, what happens? It will be converted into an integer. Then what happens? It is going to change into a, it is going to filter up. It is going to filter up and get a value. So then then the values are going to be collected. And what is the end result? End result is going to be the even numbers. Okay, end result is going to be the even numbers from the list. Okay, so I'm unable to show you there here. Okay, so maybe it got cut it down. Fine. So what are the things that I will get here? So 2, 4, and 6 will be my output. So exactly what I'm trying to say at the end of the day, you are going to, so this is again a terminal function. So this map, so this is what I mean to say, the pipeline of the functions, pipeline of the operations. So pipelining of the operations. So what I'm doing here, I'm pipelining them. Okay. So in this way I can pipeline. So now what I'm doing here, the sorted method. So what was the first method? First method was map method, where each and every element is mapped with a functionality. And later on, we have seen a filter where each element was getting filtered. And then we are looking at sorted. So what exactly is sorted over here? So sorted is nothing but which is used to sort the element. So sort the element. So import java.util.arrays. So as I told you, so arrays is a part of java.util. List is a part of java.util. Collectors is a part of java.util.stream. And you have all of them being used over here. So what exactly I'm trying to say? I'm trying to have a list. So now in the beginning, we have only numbers, and later on we had only strings. So we have strings now, but they have numbers as well, which will be converted, of course. So now what we are, so here we are not going to convert, of course, so sorted, right? So we are going to sort them out. So what exactly I'm trying to do here? I have a sorted method, so which will sort the collection into a ascending order. So what exactly I'm trying to get over here? I'm trying to get them in the order of the Unicode values, order of the Unicode values. So what exactly are Unicode values? Unicode values means, so where you have the numbers, so where you have the numbers, where you have uppercase characters, lowercase characters, all those things are being given, are being equivalent to the integers, are being equivalent to the integers. So for example, you have capital A. Capital A is 65. Small a is 97. So 65 is here, 97 is here. So where 1 is 49. So 0 is 48. So like this, so we have the number. So what exactly is happening here? Sorted, sorted. So this is how the sorting takes place. Once you want to put the collection of elements into sorted order, you can use the sorted. So sorted, filter, and map. These three are said to be the intermediate operations or intermediate functions. And under the stream. So who is stream? Stream is a functional programming mechanism. So then we will be talking about the terminal operations. So we will be talking about here about the terminal operations. So when I'm saying terminal operations, so terminal operations, under the terminal operations, so we have already seen the collect. So what was collect? In the previous case, you might have seen here collect. What exactly collect does? Collect is going to return the result of the intermediate operations. So what were the intermediate operations? Intermediate operations were, so what were the intermediate operations? Intermediate operations were the operations. So intermediate operations were the operations which will give you, intermediate operations were the operations which will give you the work, which will give you the filtration things, mapping things, sorted things. Means what they are exactly? They are the parts of the pipeline which will do which will do some functionalities on the stream. Okay, if you observe here, stream dot sorted. So if you have observed here in the filter, what it was doing, if you observe here map, stream dot map, and on that map we are going to filter. So in this way, you have the intermediate operations which will directly work on the stream. Then what exactly this terminal operations all about? Terminal operations are all about to generate the output, exactly speaking. So what exactly we are doing? Collect, for each, what they are doing at the end of the day, they are going to show you the results exactly. So that is what terminal operations are all about. Terminal operations. So now you can see arrays dot as list 2, 3, 4, 5, 3. What exactly I'm trying to say, get from here? I'm trying to have a list of numbers. I'm trying to have a list of numbers. So what I'm doing here, mapping each element to make them squared, means each element will get squared from here. 2 square, 3 square, 4 square, 5 square, and 3 square. Then we collect. So collectors dot to set. So to set in the sense what? So previously we were making them to list. But here, if you observe, we are making them to set. So set and list are the nothing but the collections. So set and list are nothing but the collections. Dot collect collectors dot list. So sorry, collector of collectors dot to set. What we are getting? We are getting 4, 9, 16, 25, and 9. What exactly these are? These are the squares of these numbers. So these are the squares of these numbers exactly. So that is what a collect is going to do. So what the responsibility of collect over here? The responsibility of the collect is to take elements from the stream. So most often than not, taking a collection of intermediate operation elements. So after the intermediate operations, generally after the intermediate operations, only you will have a collection. You will have a collection. So collect collectors dot to set is one thing, to list is one thing. Okay. So then it is all about for each. So when I look at this for each, I always remember for each loop. So what was for each loop? For each loop was the one which was introduced from Java 1.5 version. So that is where the Oracle was taking over Sun Microsystems. So initially it was of Sun Microsystems, James Gosling and his team, so which worked at Sun Microsystems for getting all these things done. So slowly when Oracle took over, so they were making a lot of changes. So for each loop was one of the changes that were made after the Java 1.5 version. So for each loop, what exactly was for each loop? For each loop was an alternative to access the elements of an array. Exactly. So access the elements of an array. So now here for each method, so the technique is the same, of course. The technology, or you can say the technique is the same, but we are acting it on the stream. So now if you observe list number arrays dot as list, so we have 2, 3, 4, 5. So we have 2, 3, 4, 5 as the list. So number dot stream dot map. So what exactly we are doing again? We are squaring each number. So that is what it is. So 2 square, 3 square, 4 square, and 5 square. And then you have for each y, you can say system.out.println of y. So exactly what it is doing, it is making each and element to get printed. It is making each and element to get printed. So what for each is doing? For each. So what up to here, what we understood? So we understood that it is list. So with 2, 3, 4, 5 upon the stream, number upon the stream. So and then we are attaching map. So dot map x tends to be x into x. Then we have for each. So where y system.out.println of y in the sense. So each element to be printed. Then we are going for 4. So how I got 4? So 2 square 4. So then I got 9. How I got 9? 3 square 9. So then I got 16. So how I got 16? 4 square. So then I got 25. So this is how I get the things done. So now 9, okay, I think, yeah, so it's an extra input. No problem. So, and then we are looking at reduce. What exactly reduce is going to be? So most often we use for each and collect. So, and sometimes we can also go for the reduce. So what exactly reduce is going to do? So reduce is going to, so generally whenever I'm saying collect and for each, so it is going to take elements and print as a sequence. But here when you say reduce, so reduce will take a sequence and return a single value. Okay, so reduce method takes a binary operator as a parameter. So what does reduce take? Reduce take a binary operator as a, so reduce take a binary operator as a binary operator as a parameter. So what exactly it is going to take? It is going to take a binary parameter, I mean binary operator as a parameter, means it is going to work. So now for example, I have these numbers. So 1, 2, 3, 4 up to 10. So the it is a collection or uh, I can say collection. So what is it? It's a collection of numbers from 1 to 10. So then I have a reduce function. So when I'm saying reduce, so it is going to take up the stream of numbers. It is going to take up the stream of numbers and it reduce a comma b. What exactly is a comma b here? So a comma b, it is going to take first two numbers, is going to add. So then the result of the first two numbers is going to be added. And in that way, so it is going to take up and it is going to give you this answer. So this is how we dealt with all the terminal operations. So what all we have talked about: reduce operation, which was a terminal operation, and then we have for each, which is also a terminal operation. So then we had a discussion on collect, so which is also a terminal operation. So what are the three terminal operations that we are talking about? Collect and for each and reduce. And before that, we also talked about the sorted, which is a sorted, um, which is intermediate operation along with our, so along with our filter operation. So along with our filter operation, and then you have the, so the, and then you have the, okay, so so and then you have the okay, and then you have the map operation. So you have the map operation. So generally what we are trying to say here at the end of the day, so we are trying to say that, so these are the intermediate operations. So map, filter, and then we also had a discussion on how we can create strings. So this is the, these are the things that we have learned today. So what exactly we have learned? So we have learned about the functional programming. So what exactly is functional programming? Okay, so what exactly is functional programming? So functional programming is all about the programming techniques. So the programming techniques, so which reduces the use of the looping structures, which reduces the programmer's effort, so which reduces the programmer's effort, so so that he can use, so he can use the concept of the streams. So where the streams will help you out in accessing the objects in a collection. Okay, and we can apply the techniques such as intermediate operations, the terminal operations, and everything. Okay, so this is all about the today's session. Hope everyone uh, hope everyone is clear with it. Thank you.